Okay, let's do some descriptive statistics in our software JASP. So I have given you the Excel version of a data file as well as the CSV version of a data file, and it is just called data. The Excel version, let me open it. The advantage of the Excel version is that you may not be able to figure out what all these column headings mean, right? So they are abbreviated column headings. So in the Excel version, there is a codebook sheet where I tell you what the survey question was. So this see-sci is actually the question, I see myself as a science person. And this was actually given to math and science students. So anywhere you read science, it's interchanged with math, depending on whether the student was in a math or science class. And again, this is just data that we're playing with. Just reminding you, this was data given to middle school students and high school students throughout rural South Carolina. Questions here, the subject questions, math through computer programming. These were asking students, how interested are you in having a career with mathematics or with statistics or agriculture? These questions, the success through outdoor recreation, these are kind of life aspiration questions. So how important is it being successful in your line of work or having lots of money? And then I give you gender and race. And race was originally a 7-category question. And I also give you a dichotomized version where 0 is white, 1 is minority. You can look at by subject, so we can look at the math versus science students. And then I also give you calculated averages for the rural life aspirations, and I tell you which of the items were put together to get that rural life aspiration factor, as similarly material aspirations, modern aspirations, and then rural identity. All right, and again, the rural identity questions were up here. We used those last week. How well do you identify with these statements? Like, I have a clear sense of my rural background and what it means to me. All right, so this is our data, and we may be playing with this for a couple weeks, but let's descriptively look at it. So the one thing I always say to students is when you have a lot of data, and you'll notice here we've got a lot of data. In fact, we have over 7,000 students in this data set. The last thing you want to do is scroll through Excel. And as we scroll, we certainly don't have any idea what the pattern of the numbers may look like. All right. And just as a reminder to repeat what I said last week, these survey questions are on Likert scales, and I am treating these as interval continuous data. Remember, we could make the argument that they may be more ordinal in nature, but for right now, we're just going to treat them as continuous. So there's equal spacing between the 1 and the 2 and the 5 and the 6. All right, so let's take a look at this data in JASP. So we've got JASP opened, and I'm going to go to my computer and my desktop, and I'm going to open the data.csv, and we see it come up. All right, and so we are looking at our data here. We can scroll through all the column headings, and of course we can scroll down, but we don't really want to do that. All right, so how do we start looking at descriptives? So this one reason I love this software, it's nice and intuitive. We're going to go to descriptives and descriptive statistics. All right, and so this is our worksheet here. I'm going to go ahead and open the plots as well as the statistics drop down so we can see all the options available to us. All right. And so let's talk about variables and let's talk about split. So variables, we will put anything here we want. Okay. You can put nominal, ordinal, discrete or continuous. So we are going to put, again, any variable. We could pick one. I see myself as a math or science person. All right. And the default is that we're going to get our sample size, how many are missing, the mean of this 1 to 6 point Likert scale. And again, the minimum and maximum is what tells us it's a 6 point Likert scale. And we get the standard deviation. All right, so we are treating this as a discrete variable. We could do a distribution plot. All right, so this is basically going to look like a histogram. And we could see how the 1s to 6s are distributed. So 1 is I absolutely do not see myself as a science or math person. 6 is I very much do see myself as a math or science person. So we see that many more students are either somewhere in the middle or on the lower end of the spectrum of really identifying with math or science. The display density just draws a curve, gives us an idea, and it should. It's not going to give us a curve for some reason. Well, we'll have to do that later. I have tested this out on a few variables, so I know that we can get a display density. Basically, a density is going to give you a continuous curve that trends that data. All right, we could get a box plot. So we talked about this in the data. And again, we're not getting a box plot here. I'm not sure why. Oh, there we go. Just took us a minute. All right, so here's our box plot. And of course, here we're seeing our median of roughly a little bit more than 3 or right at 3. And we're seeing how our data is distributed. This box plot is showing us that this interquartile range hovers over the middle to low numbers, exactly like what we're seeing here in our distribution. All right. For central tendency, we can get mean, median, and mode. All right, and so here we see our median and mode are both 3. Our mean is 3.103. So what is this telling us? Here, the mean and median are very close, which is telling us that our distribution is relatively symmetric. We're not really skewed to the right or the left. The mean is a little bit to the right of the median, which says we could be right-tailed, but we're not really seeing that. All right, we've got our standard deviation. Standard deviation alone, that 1.587, is not necessarily easy to interpret, but what it's telling you is how spread out our data is. And if we're just talking about the standard deviation by itself, it's a lot easier if we have another standard deviation to compare it to, which we'll see in just a minute. All right, we could certainly have the variance too. All right, so here's our variance, 2.52. But as I mentioned in the measures of variability video, variance is in squared units. So this would be 2.52 in the squared Likert scale, which doesn't make sense to us, and so it's absolutely impossible to interpret a variance number. All right, we don't talk about it in this class, but I will certainly tell you skewness and kurtosis. All right, so here we have our skewness and our kurtosis. These are numbers that tell us how close our data might be to a normal distribution or symmetric distribution. So this is telling us that our data is slightly skewed and slightly kurtotic. All right, let's see. All right, so what's something we could do with this? And I tell you what, let me go ahead and uncheck kurtosis and skewness and variance because we're not really interested in those, and we're not really interested in the mode. All right, so, and we don't really want a box plot. Okay, so maybe you would like to see a frequency table. Because Likert scales jump back and forth between being interpreted as ordinal and being interpreted as discrete interval. We could check our frequency table here, and here we see our frequency table. Now, one of the things you probably thought as you were going through the videos is, oh my goodness, frequency tables seem really difficult to construct. And for the longest time, I taught frequency tables. I taught doing them by hand. But as you can see here, we have nearly 7,000 kids. You cannot do a frequency table by hand on 7,000 kids. And so it's so important to be able to get these in our software. And as you can see, it's as simple as checking a box. But we have for each value of the Likert scale, we have our frequency, so how many kids answered that particular number, and we get our percent that number represents. So this percent is also called the relative frequency, and it must always sum to 100%. All right, and then here's the cumulative percent, which I referred to in the video as the cumulative frequency. All right, and so we see, just as we did with our distribution here, that the majority, we have pretty uniform distribution of kids answering 1 through 4, and then we have just a few kids answering 5 and 6. All right. Now, let's uncheck frequency table for a minute. Now, what's something interesting that we could look at? Well, remember, I told you that this I see myself as a science person was actually given to math and science kids. So that it was in these numbers, we have kids saying, I see myself as a science person and I see myself as a math person. Wouldn't it be nice to kind of tease apart the science students from the math students? Well, we can actually do that, and that's what this split allows us to do. It allows us to split looking at this variable by another variable, and we have the variable subject here, which we can move over into split. All right. 1 is math and 2 is science, and this is stated in our code book in the Excel spreadsheet. And so what we're seeing here, all right, let's just look at our means for a second. This is pretty interesting. So 1 is math. So on average, students are saying that they see themselves as a math person more than they see themselves as a science person. It's interesting that science identity is quite a bit lower than math identity. All right. As far as standard deviation goes, now we have 2 numbers, so we have a comparison here. And what this is saying is that math identity is a little bit more spread out because the standard deviation is bigger or slightly bigger. Again, we can say that the distribution of the math students is more spread out. And so we see that, right? So here we see that we have roughly uniform distribution for our math kids, all right? Whereas with the science kids, we do kind of have just a few students answering that they definitively see themselves as a science person. It's interesting, math always gets the bad rap of being the one that being the subject kids hate and fear, and it's been interesting in this data set teasing apart some of the motivation variables by subject and seeing that science motivation and science identity are actually much lower than math motivation and math identity. All right, so let's go back to our descriptive stats. All right, so what's something else we could look at? How about rural aspirations? So in rural aspirations, this is going to be wanting to live close to your parents, wanting to be a part of your community, kind of traditional rural values. All right, and let's get a distribution plot. All right, and so we see here that surprisingly, most kids value these rural aspirations. All right, so this would be clearly what is called a left skewed distribution. We say left skewed because the tail is over on the left. All right, and so while our median is going to be up here, and let me go ahead and check the median box so you can see our median is going to be to the right. So our median is up here, whereas our mean is pulled a little bit to the left. See, it's smaller than the median by these few low values down here. So a few students absolutely have no rural aspirations, but interestingly enough, the majority of kids do in fact value living close to their family, living close to their friends, being a part of their community, living near open land, having outdoor recreation available to them, and things like that. All right, but maybe we want to say, well, maybe that's more boys than girls, or maybe that's more girls than boys, right? Do boys and girls value rural aspirations equally? All right, well, that's a great question. So why don't we go back in here and pick our gender and add that to our split. And so now we're looking at rural aspiration by gender. And again, we can consult our code book, but I'll tell you 1 is female and 2 is male. All right, and so we see here that males have a slightly higher mean and median, but males also have slightly more variation or spread in the data. All right, and so here is our females, and then here is our males. But it's actually surprisingly similar. We don't see a huge difference in how kids are valuing rural life aspirations across gender. All right, what about, let's just take this off, and what about between, now I'm going to go with something else dichotomized for simplicity, but what about across the dichotomized race of 0 is Caucasian and 1 is a minority? All right, and we see here that the Caucasians value the rural aspirations. Even though the median is equal, we see that the mean is pulled, is higher. So what that's telling us is that we actually have more minority students down here pulling the mean more to the left. But again, it does look like, let's see here. Again, it's not very different across Caucasians and minorities. All right, so what I recommend you do, your main assignment is going to be another written one this week. I will post a few practice problems for you to practice a few things by hand. But what I really recommend you doing is there are still a lot of variables in here. And I recommend you just playing with these variables, getting some descriptive statistics, looking at distribution plots and frequency tables, and maybe even some box plots. Feel free to investigate the percentiles. And if you have any questions with anything in this data, feel free to contact me.